Greetings to every one of you. So in this video we are going to discuss a topic 2D representation of arrays in memory. Let A be a two-dimensional m cross n array. It can be represented in the memory by a block of m cross n sequential memory locations. As we know that the array require the continuous block of memory. There are two ways of representation. One is row major representation and another is column major representation. In case of row major representation, so the value of the array will be stored in the memory in the form of the number of rows, that is row by row. For example, let us consider this is the array given, and if you represent this array in the memory in the form of the two dimension, so the values will be that is stored row by row, 10, 20, 30, 40, 50, 60, 70, 80 and this is 90. Similarly, the same array can be represented in the form of the column major representation as follows, that is 10, 20, 30, 40, 50, 60, 70, 80 and 90. So this is a given array, it's a one-dimensional array. So here we represented in the form of a matrix in row major representation. This is a one-dimensional array that is given, and we represented this array in the form of a matrix using column major representation. So both these representations are available. Okay. So next important topic is address calculation in two-dimensional array. Let A is a two-dimensional array of m cross n size. To compute the location of any given value, for example a of j comma k, using the formula location of a of j comma k is equal to this base of a plus w into n of j minus 1 plus k minus 1. If the array is represented using row order, if you want to calculate the address, we have to use this formula. So where base of a is equal to the address of the first element of a, and this w is the number of words per memory cell. So you can say that the word is nothing but the byte, and n is the total number of columns in the array. Similarly, if you want to calculate the address of the particular location, if the values are represented in column major representation, this is the formula. So location of a of j comma k is equal to base of a plus w into m of k minus 1 plus j minus 1. This is for here m represent total number of rows. In order to understand this, let us have a problem. Consider 25 cross 4 matrix array A. Suppose the base of A is equal to 200, the starting address, and this number of bytes per memory cell, it is 4. Calculate the address of this particular location, that is A of 12 comma 3, that is the 12th row and the third column, using row major order. This is row major formula and this is column major formula. So now just to substitute the values, so we can calculate the first one. Substitute the values. The base of A, it is 200 plus the w is the number of bytes, that is 4, and this n value, it is 4, j minus 1 it is 12 minus 1, that is 11, plus k minus 1, k is 3, so that is 3 minus 1, that is 2. So 200 plus 4 into this is 44 plus 2, that is 46. 4 into 46, it is 184. So this is 200. So our result is 384. So that is the address of this particular location. So similarly, in column major representation, this is the formula. Location of A of 12, 3. So the base of A, it is 200, plus the W is the total number of the bytes, words per memory cell, that is 4, into this M value is 25, that is the row value, and this K minus 1, it is 2, plus J minus 1, it is 11. So 200 plus this is 4. So this is 50 plus 11, that is 61. So 61 into 4, that is 424. It is 200 plus 244. So the value of the address, it is 444. So this is how we can do the calculation, and we can find out the address of any particular location. So in this video, we have discussed how this two-dimensional array can be represented in memory. So that can be done in the two ways. One is row major representation and another is column major representation. And also we have discussed how to calculate the address of a particular location using this row major as well as the column major representation. I hope you understood the concepts. Thank you. Keep watching.